All right, kiddos, I wanted to go over the homework from last night with you. It was on 2.1. 2.1 was on inductive reasoning. In class, we talked about the difference between deductive and inductive. Deductive is when you have a general rule and you are going to a specific case. So, like I said, a general rule could be all mammals are warm-blooded, and then the specific case, I am a mammal. What do you know about me? I'm warm-blooded. Okay. When you're talking about inductive reasoning, you have specific cases and you're going to go to the general rule. Now, usually deductive reasoning is a better way to think. Inductive reasoning definitely has its benefits and its uses, but you have to be careful because sometimes you think you see patterns that don't actually exist. So let's go ahead and jump into this. The type of patterns that we were looking at and the way we were using inductive reasoning was by looking at sequences. So a sequence, an example is right here. We have the different elements or the terms inside of our sequence. We have 4, 7, 10, 13, and we are trying to use inductive reasoning to figure out what is going on. Now going from 4 to 7 is adding 3. It's also multiplying by some number. But then this one I see is also adding by 3, and this one is also adding by 3. So I'm looking at those specific cases and I'm coming up with a general rule. I believe the general rule is going to be that you just add 3 each time. So the next one is going to be 16 and 19. Okay, so I'm assuming that's what you guys got as well. Now the next one, I'm looking at this. This one could be subtract 15 or it could be multiply by -2. So I look at the next one and I see that that one is not subtract 15, but it is multiply by -2. And this one is also multiplied by -2. So I come up using inductive reasoning to figure that my pattern is going to be multiplied by -2 each time. So the next one is going to be 80 and then -160. Now the next one is a bit more challenging. It goes 3, 4, 6, 9, 13. So I could be adding 1, but then if I add 1 again, I don't get to 6. I could be multiplying by some number, but then it's not multiplying by the same. So I take a look here and I find out that this is going to be adding 1. If I'm just looking at adding, then that's adding 2. That looks like it's adding 3, adding 4, adding 4, and then you have adding 5. So that looks like a pretty surefire pattern right there. So the next one is going to be add 6. We add 6 to that, you get what, 24. And then when you add 7, you are going to get 31. So that's what I would say the pattern is right there using my inductive reasoning skills. Now the next one, 1 becomes 2, 2 becomes 2, 2 becomes 4. What is going on here? Well, me personally, I see that those multiply to get 2, these multiply to get 4, these multiply to get 8, these multiply to get 32, and then I'm going to have to use a calculator on that because I can't do that in my head very easily. 32 times 8, that's going to give me 256. 256. And I'm going to do 256 times 32, and that's going to give me 8,192. Now the next one, I have 5, 6, 11, 17. Well, I already see that that plus that gives me this, that plus that gives me this, that plus that gives me that. So I'm just going to be adding the previous two terms, 17 plus 28, and the next one is going to be 45, and then I'm going to do 45 plus 28, and it gives me 73. Okay, OTTFFSS. It's got to be real world. I'm probably going to connect it to numbers because it's a math class. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Remember I told you guys the 3 things, or I think it was 4 things you could check. First, see, are you adding, subtracting, multiplying, or dividing by the same number or different numbers each time to get from one number to the next? Does it have to do with the term number? So this one would be a real world one having to do with the term number. first term, second term, 1, 2, 3. The next one would be real world. And the last one would be, does it have to do with? Does it have to do with previous terms? So usually you're looking at multiple, like these two, we're looking at the previous two terms. Okay, the next one we have 1, 8, 27, 64. I'm going to think that it has to do with the term number. So this is the first term, second term, third term, fourth term, fifth term, and then this would be sixth and seventh term. And I see that each one of these is cubed. Not quite sure if you guys knew your perfect cubes, but 6 cubed would be 216. This one's 216. The next one, 7 cubed, is going to be 343. Next one, you have 3 sides, 4 sides, 5, 6. So this one would be 7 sides. 1, 2, 3, 4, 5, 6, 7. The next one would be 8 sides. 8 sides. Okay. So those ones we're all looking at sequences and figuring out the next two terms using inductive reasoning. Next one says, give a counterexample for each of the following. When you square a number, it gets larger. Well, when you square a number, it gets larger. Let's think about this. What about when you square a fraction less than 1? 1/4 times 1/4 gives you 1/16, and 1/16 is smaller because this is 0.25, and 1/16 is 0.0625. So here would be your counterexample when you are looking at a fraction greater than 0 and less than 1. The next one, when an item gets older, it gets worth less, or it is worth less. Antiques. So when you think about antique cars or something like that, a lot of times antiques will be worth more as they get older. It is always winter in December. Well, that would be true if you are in the northern hemisphere. But if you're in the southern hemisphere, if you're down in New Zealand, December is actually going to be summer. So you could say southern hemisphere would be an example. When you add two consecutive numbers together, the result is bigger than the first number. Well, let's think about this. What about if you had like -3 plus, let's see, consecutive numbers, -2. Those are consecutive numbers, and that gives me -5. Is that bigger than the first number? Nope. When you think about a number line, further in this direction into the negatives is going to be getting smaller. Further into the positives is going to be getting bigger. Okay. So let's take a look here. Come up with two different sequences, first 5 terms, and explain what the pattern is. Now, obviously, these ones, the answers are going to vary. Answers vary. I'm assuming you guys probably did one where you were adding each time to get from one to the next and then multiplying, but there's many different sequences you could use with different rules. So hopefully that explains the homework. Once again, it's nice to go over and look through the 4 different first things to check out when you're trying to figure out what the next terms are, but sometimes you just got to sit there and throw out ideas until something pops up into your head and works. All right, thanks for watching.